All right, guys, so we have a little bit more to learn about trigonometry. Trigonometry is study of triangles. A big part of that is angles. So today we're going to focus just on angles. We're not going to do sine, cosine, or tangent or have triangles or anything like that. We're just going to talk about angles. And one of the important things to learn when it comes to this is that there's actually two different ways to measure angles. Throughout your prior learning, you probably have learned a lot about degrees. You know that a right angle is 90 degrees, that you measure an angle in degrees. Acute is less than 90, there's obtuse, there's, all this things about degrees. A full circle, for example, is 360 degrees. But what a lot of people don't know is there's actually two different systems for measuring angles. Kind of like metric and standard, you can measure length in inches or centimeters, or temperature can be Fahrenheit or Celsius. With degrees in angles, there's two systems. So degrees obviously is one. The other is called radians. So I guess since you know probably a lot about degrees, we're going to basically be introducing radians today. So there are two different units for measuring angles, degrees and radians. If we want to focus on degrees for just a minute, there are 360 degrees in a full circle. If you had a slice of pizza whose angle is 1 degree, you would not get much pizza, right? A degree is a very thin sliver. There's 360 of them to fit in a full circle. A half circle, there would be 180 of them, 180 degrees in a half circle. A radian is different. So here's where a radian comes from. So imagine you have a circle, and you know the distance from the center to the edge. Here, let me change color so this stands out a little bit better. Center to the edge is called the radius. If you take that exact same length and connect two endpoints of radiuses together, not in a straight line to make a triangle, but in a curved line along the circle, but that length is also r, it creates an angle, and that angle is called 1 radian. So that is what a radian looks like. It's obviously much bigger than a degree. If you had a slice of pizza that is measuring 1 radian, that would be a decent amount. That would be like a regular slice of pizza, even a little bit bigger than most. So a radian, a single radian, is substantially larger than a degree. A degree, by comparison, might be something like, that big or even smaller. So a radian you get by sort of wrapping a radius length on the outside of a circle, and then the angle that's created is called a radian. Now, a half circle, if you look at this diagram, I kind of freehanded it, but it's fairly accurate. A half a circle, which is right here, contains 1, 2, 3 radians plus just a little bit more. So a half circle contains just over 3 radians. What's interesting is what that just a little bit more angle right here is. That just a little bit more, if you can believe it, do you want to take a guess at what it is? That little bit more is approximately 0.14159. And so what we have is a half a circle, which we know is 180 degrees, is pi radians. And that's kind of where pi comes from. So 3.14159, blah, blah, blah. 3.14 radians make up a half a circle. So that means 180 degrees equals pi radians. Now, the goal of this lesson, besides sort of getting a fundamental idea of what a radian is, it comes from wrapping a radius around a circle. It's a pretty decent sized slice of pizza, general information like that. The main goal is to be able to do conversions. If you are given a number of degrees, can you convert that to radians? And if you're given a certain number of radians, can you convert that to degrees? The process is fairly simple. It involves fractions, which a lot of people don't love, but I'm going to show you a trick on Desmos to sort of get around that. And that's our goal then, convert. So To convert from degrees to radians, you multiply by pi over 180. Technically, it's pi radians over 180 degrees, but we're not going to worry about labels right now. To convert from radians to degrees, you multiply by 180 degrees over pi radians. So pi over 180 and 180 over pi, those are called conversion factors or scale factors. Fairly typical when you do any conversion. I don't know if you've ever had a science class where you have to convert from like degrees Celsius to Fahrenheit or inches to centimeters or whatever, but usually it involves multiplying. Often it involves fractions and labels and stuff, but we're making it fairly simple. So these are the two rules: multiply by pi over 180 or multiply by 180 over pi. Oops, I'm getting reminders. Sorry about that. So the first page of the assignment is 8 problems. You'll only do the odds, so 4 problems of converting degree measure into radians. And then the second page, same number of problems, convert radian measure to degrees. So let's do this. Convert negative 260 into radians. So the rule is you multiply by pi over 180. Now, pi, there's 2 ways to look at it. You can treat pi as 3.14 or 3.14159 or some rounded off value. In fact, there's even a pi button on the calculator. So you can do that, and that would give you an approximated rounded off answer. Or you can treat pi like a variable. Even though it's a number, you treat it like a variable and just leave the pi symbol as part of your answer. And that's what we're going to do. We're going to leave pi as a symbol. So we need to do negative 260 times pi over 180. Well, okay, so you put this over 1. Top times top is negative 260 pi. Bottom times bottom, 1 times 180 is 180. And now we're looking at reducing that fraction. And reducing fractions, you know, there's things you can do like, oh, you can cross out zeros. If these are both even numbers, you divide by 2, et cetera, et cetera. Let me show you something really slick that Desmos does. So I'm going to hit the fraction button. Negative 260 divided by 180. Now that gives me a decimal answer, but I don't know if you can see right there, there's a little symbol that looks like this. I'm not sure if we use this in class or not, but when I hit that button with my finger, it makes a fraction out of it. So I get negative 13. It does bring the negative out front. Negative 13 over 9. All you have to do now is extend that fraction bar a little bit and put that pi symbol up there with it, and that's the answer. So we have a fairly easy way to handle the fractions in this worksheet. So it shouldn't be any issue at all. Let's look at number 4. Multiply by pi over 180. If you need to, you can put this over 1, but after you do a few of these, you just learn, oh, the top number goes on top, the bottom number goes on bottom. Now, let's look at 225 over 180. Again, I'm going to hit that fraction button right there. Oops, got to hit it. Okay, 5 over 4. Let me erase that arrow. 5 over 4. So this works out to be 5 over 4, but you put a pi up on top because that's where the pi symbol was. Now, if you actually needed a decimal, you could do 5 times pi over 4, and that would give you a decimal answer, but we're just not doing it that way. All right, let's look at number 6. Again, multiply by pi over 180. So that's going to be negative 30 pi over 180. If you want to put this over 1 and do top times top, bottom times bottom, you're welcome to do that. Hopefully you won't need to. So I've got negative 30 over 180, and I hit the fraction button. It works out to be negative 1/6. Again, it brings the negative out front. You put the pi symbol up there with the 1, negative 1 pi over 6, or you can just call it negative pi over 6 because multiplying by 1 really doesn't do anything. That's it. All right, let's do this last one and then move to the next page. So we need to multiply by, again, the conversion factor, pi over 180. So that's going to give us negative 330 pi on top and 180 on the bottom. negative 330 on top, 180 on the bottom. Hit that fraction button. Negative 11/6. Extend the fraction bar a little bit and stick the pi symbol up there, and there you go. So that is the process in 4 repeated examples for your viewing pleasure of how to convert degrees to radians. Now let's look at the flip side. Convert radians to degrees. So the rule here is to multiply by 180 over pi. Now, the pi on top and the pi on bottom will always cross cancel. And that just leaves us with 180 over 18, which again, we can do on a calculator. 180 over 18, of course, is 10. Stick a little degree on there. 10 degrees is the answer. Oh, by the way, I have not been checking myself, have I? Let's see. Let me do this real quick. Negative 13 pi over 9 for number 2, check. 5 pi over 4 for number 4, check. Negative pi over 6, negative pi over 6, check. Negative 11 pi over 6 for number 8, negative 11 pi over 6, that's good. Number 10 should be 10 degrees, and there it is. Okay, so we're doing fine. Number 12, again, multiply by 180 over pi. The pi's will always cancel out. We're left with 2 times 180 over 3. And that's something you can work out, but you can just use your calculator. 2 times 180 over 3 is 120. Stick a degree symbol on there, and you're good. Now, you might think that I did something wrong. It should be 2 times 180 like this over 3. But that gives you the same answer. There's just 2 different ways of typing in the same thing. So 120 is the answer. And right there. Number 14, multiply by 180 over pi. The pi's cancel out. I get negative 9 times 180 over 4. Negative 9 times 180 over 4. Negative 405 degrees, a negative 405 degree angle. By the way, yes, you can have negative angles. You can have positive angles, of course. You can have angles bigger than 360. This is all a thing. If we were in class, I'd do various diagrams of angles that exceed negative 360 and what does it mean to go in a negative angle as opposed to a positive. Don't worry about that right now. Just focus on the main skill that we're doing, which is the conversion. All right, number 16, last one. Multiply by 180 over pi. Once again, the conversion factor, 180 over pi. The pi's cancel, leaving us with 180 on top, 4 on bottom. 180 over 4 is 45 degrees, and there it is. Now, when your answer is in degrees, you are supposed to put the degree symbol on each answer. It's considered the appropriate, proper thing to do. Up here, you might argue, if you're the argumentative type, and I don't blame you if you are when it comes to math, because there's so many rules, and you see one broken, it might sort of rub you the wrong way. You might say, okay, negative 13 pi over 9, this answer is an angle in radians, so aren't you supposed to write negative 13 pi over 9 radians? And that would be an appropriate observation, or perhaps there is an abbreviation for radians, since it's, we got a symbol for degrees, and rad might be an appropriate symbol for radians as well. And if you wrote your answers this way, either way, that would be fine. It has become customary, though, in higher math, that when you are working in the context of angles and you see pi in the answer, that everyone just knows that, oh, you have radians here. Pi has a lot of applications in a lot of different ways, but when you're talking angles, basically it's universally accepted that, oh, that means radians. So what happens is people just stop using the radian label over time to where it's just not really done at all anymore. So with these answers, you don't have to put a label. The presence of the pi symbol implies that it's in radians anyway, so you just leave the answer like that. Down here, you are supposed to put the degree on every answer, otherwise it's just some number. So, all right, that about wraps it up. Contact me through the normal means if you have questions. Otherwise, do the odds, check it, submit it, and have a great day. Bye-bye.